objectives of traditional dewatering. In this, we have to understand what are the various objectives which are going to involve in these various objectives for this traditional dewatering. In these dewatering, stabilize excavation sites, improve soil bearing capacity, and preventing flooding, and facilitates construction, environmental remediation. These are the various objectives for this dewatering. Coming to the stabilize excavation sites, in these, once we are going to remove the excess of the water which are going to stabilize soil and prevent caves or collapse during excavation. Removing this excess of water to stabilize the soil comes under this stabilize excavation sites. This is the one of the objective for dewatering. And also the soil, all we know how soil bearing capacity is important for any type of construction work which we start. So before that only, we have to understand the soil bearing capacity. So coming to the soil bearing capacity, the improvement of the soil bearing capacity is reducing the water content in soil to increase its load bearing capacity for foundations, and also what are the structures which we are going to construct below the ground level and remaining other structures also. So to improve this soil bearing capacity is also one of the objective for dewatering. Coming to the flooding. So in this, the prevention of flooding is also very important in waterlogging areas, and whenever we are going to construct different types of tunnels, dams, reservoirs, bridges which comes by rivers, any kind of water bodies, such type of things, we have to understand this flooding also. So understanding this flooding is nothing but coming to the dewatering, it is nothing but we are going to controlling the groundwater's level to prevent flooding in construction sites. It depends upon whether it is a tunnel and whether it is all other which are relevant to the underground structures. In some of the cases, the flooding may prevent in above the structures also. It may require low height bridges, low height bridges, and different scenarios also we may consider for this. The main thing is we have to prevent the flooding. And the next coming one is the facilitate construction. In this, whenever we are understanding the various activities which are creating under dry conditions to facilitate the construction activities and ensure the quality of the work, and environmental remediation. In this, once the removing contaminated water from polluted sites to enable safe cleanup and restoration activities. These are all some of the objectives which we are going to understand in our dewatering. In this, what are the various dewatering techniques? Coming to the dewatering techniques, in this, sump pumping. In this method, digging sumps or pits at the lowest points of the site and using pumps to remove water. In this method, sump pumping, it is nothing but we are going to using the pumps. Those are reciprocating pumps like that. So we are using to remove the excess water which is there in that sumps or pits, whatever it may be, based from their lowest point. From their lowest point, we are going to remove the water using the pipe system. So that is the sump pumping, that method. And in where we are using these kind of, and what are the applications means. Coming to these, if the depth is more, the deep depths is there, the deep excavations are there, such type it is not adoptable. Coming to these adoptable condition for this sump pumping is suitable for shallow excavation and areas with low water table fluctuations. So these are the conditions which we consider for these sump pumping. So whenever the deep foundations are required, whenever the water level is in very deep from the ground level, it is very down. So such types of conditions, this sump pumping is not adaptable one. Coming to these, in these advantages are, it's very simple and very less cost and cost effective. This kind of sump pumping because of the shallow depth and the whatever it, they are coming to these limitations. Again, for the deep excavations, once we require the more depth is more from the ground level. In such cases, the dewatering is required means for higher water tables also. This sump piping is not suitable. It has its own limitations. Now, well point systems. Coming to these traditional dewatering system, that is well point systems. In this, the installation a series of small diameter wells connected to a header pipe and pump to lower the groundwater level. So in this, the series of small diameter wells connected to the header pipe and pump to lower the groundwater level. In this application, it is also effective for shallow to moderate depths and sandy soils. In this, the soil condition also we have to understand. The well point system is suitable for the sandy soils and it effective for the shallow to moderate. So the previous sump pumping is only for shallow. This is for shallow to moderate depths. It is also not suitable for deep depths, and the type of the soil also important in these well point systems. Such type of soil is sandy soil conditions only we are going to apply well point systems. In these advantage, coming to these advantage, it is good control over the groundwater levels and flexibility in installation. The installation process is very flexible in this well point system. And coming to the limitation, limited depth and efficiency in cohesive soils are high water table areas. So it is also the efficiency point of view in cohesive soils. It is limited as well as the deep depths also. It is not at all one of the adaptive traditional technique. It is adaptive when effective for the shallow to moderate and sandy soil conditions. Next one is the deep wells. So drilling deep wells with submersible pumps to remove water from greater depths, from deep depths. Such type we are using these deep wells. In this, suitable for deep excavation and high groundwater levels. And advantage for effective for deep water table control and large volumes of water. Whenever the large volumes of water is there, such type of and depth of water, the depth is also more. Such type we are using this kind of deep wells. In those scenarios, we are using deep wells. Coming to the limitations, higher cost and complexity in installation and the operation. It is very cost. Whenever it is required, we are going to use for shallow depths, moderate depths. Once it is also eligible, it is also adaptive technique for using, but the cost is more. It costs more. So whenever it is required, we have to adopt, that is enough. And also the time of the installation, it is facing so much of complexity is also there in its operation also. So these are the deep wells which are suitable for deep excavation and high groundwater level condition. So in this also we are going to remove the water from the great depths. And woodcutter wells, in this, using these kind of pumps and well points to create a vacuum that draws water from the soil. In this, effective for cohesive soils as well as the deep excavation. Woodcutter, these kind of It is helpful for the deep excavation and that too for the causue soils. These causue soils is not adopted for the deep well, but in this it is adapted as well as the deep excavation. In this is suitable for low permeability soils and high efficiency. Based on the characteristics, also we are going to adopt different kind of modification technique, traditional dewatering technique. So this is for high efficiency as well as the low permeability condition. Next one is limitation, higher operational cost. It is also cost more. The operational cost is very high and also complexity is there. Now move on to the drainage trenches. This is also one of the traditional dewatering technique. It is excavating trenches filled with gravel or drainage pipes to collect and divert water away from the site. So in this, the excavation trenches filled with gravel or drainage pipes to collect and divert water from the site. These applicable suitable for areas with surface water issues or shallow ground water. So these kind of drainage trenches which we are for the suitable the surface areas of water for the or shallow ground water. In this simple and effective for surface water control. For surface water control, it is helpful whenever the heavy rains are there, whenever the rainy conditions are there in that particular locality, these kind of drainage trenches are very helpful. And coming to these limitations, it is limited depth control and effectiveness in high groundwater conditions. It is limited depth control and effectiveness in high groundwater condition. These are the parameters which we are going to understand for this drainage trench method. It is applicable for surface areas and it is the advantages is it is effective for surface water control and limited depth. Effectiveness in high groundwater conditions is difficult. The effectiveness is the limited for these high groundwater conditions. The next one is cut-off walls. In this method, constructing impermeable barriers, example slurry walls, to block groundwater into the excavation area. Such type is nothing but the cut-off walls. In this, we are going to constructing impermeable barriers. It means slurry walls to block groundwater flow into the excavation area. Already excavated area is there. So we are going to block using cut-off walls. And it is suitable for sites with high groundwater pressure and large excavations. Groundwater pressure is more and large excavation is the applicability of these cut-off walls. We may adopt in these conditions these cut-off walls. Coming to the advantages, effective in controlling groundwater flow and reducing dewatering needs. So in this, the effective controlling groundwater flow. So we are going to control the groundwater flow and reducing the dewatering needs. High construction cost and complexity is the limited for these cut-off walls. High construction and the complexity, high construction cost. Now, choosing the right dewatering technique. So till now what we understand, what are the various traditional dewatering techniques and what are the various situations and what are the various applicabilities are there. We observe all these things till now. Now coming to this, choose the right dewatering technique based on the various parameters we are going to understand. In that, soil type and the depth of excavation, groundwater conditions, site conditions, environmental parameters. These are all the various things which we are going to choose the which type of dewatering technique is suitable for that particular scenario. In this soil type, sandy soils are more amenable to well point systems. Koju soils, it is for deep wells or reductor wells. Now coming to the based on the soil type, sandy soils, such type of soils we are going to choose well point system. Koju soils we are going to choose deep wells. Now coming to the depth of excavation. Coming to the shallow excavations can use sump pumping or well point systems, while deeper excavation may need to deep wells. So it depends upon the depth of excavation. For shallow we may use different types. Shallow to moderates we are considering the other types of that well point systems. Those are useful for the shallow to depth. For shallow, sump pumping. Deep few are there, well point deep wells like that. So based on the type, based on the factor, we are going to choose the dewatering technique. Now groundwater conditions. High groundwater levels and flow rates require more robust systems like deep wells or cut-off walls. Site conditions. The presence of surface water, site accessibility and space constraints influence to the choice of technique. The choice of technique depends upon the surface water, site accessibility and the space constraints also plays a role. And also one more important is the project budget. The cost of installation, operation and maintenance of dewatering system must align with the project budget. Environmental conditions. So potential impacts on the surrounding environment and compliance with regulatory requirements must be considered in environmental considerations. Now conclude all these points till what we understand, consider it as a summary. So here, what are the objectives for dewatering, what are the various methods, and what are the various objectives for traditional methods, and what are the different traditional methods, and choosing of those techniques, dewatering techniques based on the traditional dewatering techniques, how we are choosing those based on the various parameters. These are all the overall we have to understand the how we are going to dewatering the required thing based on the various parameters as well as the which type is adaptable for the condition in traditional point of view. Like this, these are the things till now what we understand. These traditional dewatering techniques are essential managing water in construction and excavation projects, assuring safety, stability, efficiency are the parameters. Coming to the selection, an appropriate dewatering methods involves careful consideration of site-specific conditions, soil properties, groundwater levels, and project requirements. So, by choosing the right dewatering technique, project managers can achieve optimal results while minimizing the cost and also the environmental impact. So, these are all the things which we are going to understand in our traditional dewatering systems and their choice of adaptability. So, these are all the some of the web references which we choose for this better understanding. So, these are helpful for getting more things and in so these are the web references which may go through, and it gives the more information regarding this traditional dewatering as well as the how we are going to choose the type of the dewatering for the particular condition and particular locality or particular region or which type of construction it is. Thank you. We will see in our next class.
Like, share and subscribe. Hit the bell icon for more updates.